As Peter said, my name is Momchuk Binev. I'm a product manager at the Imaging Source. And today I would like to speak about embedded vision, one partner, one solution, complete confidence. Let's start with some typical application examples for embedded vision. And I'm sure that all of us have seen them already around us. This could be some robots in retail. It could be, of course, in medical and life sciences. There are surely these autonomous mobile robots, agricultural applications for sure, and a lot of possibilities in drone applications. And this is just a fraction of where we see embedded vision nowadays already, actually since years. Yeah. So I myself always ask myself, what is actually inside when I see these examples? And in all of them, there is surely some kind of processing unit. If it's really embedded, it could be an NVIDIA system on model, it could be NXP, it could be even Raspberry Pi or Qualcomm or anything else. You surely have some carrier board because you want to connect peripheral devices and control them. And when it is about imaging, then surely you also need to connect cameras. This could be board level. This could be also with housing, also maybe with IP67 protected housing. Of course, you need some lenses. You need cables like FPC cables for MIPI cameras or coaxial cables for GMSL2 cameras. In some cases, maybe you need also deserializer boards to connect the GMSL2 camera or FPD-Link camera. And of course, you need a board support package, so the operating system and drivers for the cameras. In case of NVIDIA, it's typically Jetpack, or it's always Jetpack. In case of NXP, probably it's a Yocto-based board support package or anything else. And in I would say most of the cases, you use the GStreamer as the de facto framework to do the image processing. It could be pure deburring, or it could be encoding, it could be AI or anything else. And this all is actually just the basis for the customer, could be OEM, could be end customer, could be a system integrator to build the final solution around this. And logically, a very important question to ask is it actually plug and play? Or to put it in another way, what happens actually when you combine cameras, cables, carrier boards, system on models, software from different manufacturers? And yeah, how confident are you that everything will simply work out of the box? And to be honest, in most of the cases, it doesn't. That's the truth, that's the reality. But to put this question in another way, so how have you considered how much risk, development time, and costs can be minimized by using single source solutions that actually offer the end-to-end embedded vision ecosystem that actually the customer is looking for? And yeah, this question has been basically our question, and for the last years, I would say so. And we try to answer this question by pursuing a single source solution approach. This means that we decided to offer more than just cameras, and in our ecosystem, we call them reference designs. These reference designs are designed both for mass production and for evaluation purposes, for sure. We currently offer reference designs based on NVIDIA Jetson Orin and on NXP IMX8 Plus. And as you see, we deliver everything, starting with cameras, lenses, cables, the system on model, the carrier board, of course, the board support package with operating system, with the drivers pre-installed and an SDK, so that actually you can simply unbox it and get an image immediately. And then, of course, start focusing and then working basically on what you actually want to do. For example, the image processing could be classical or AI, or, of course, building the complete solution. So a very interesting question actually in every project is, what is the right camera interface? And to be honest, we see everything and we don't make the mistake to limit ourselves or our customers in the camera interface. For us, embedded vision is anything that solves the customer problem. And it could be a USB 3 camera with a Type-C connector, which supports both USB 3 vision and the USB video class, for example. It could be a USB 2 camera. It could be a USB camera via PicoBlade. Yeah. Of course, it could be also a classical MIPI CSI-2 camera or interfaces derived from MIPI CSI-2, like GMSL2 or FPD-Link, with housing, without housing. And of course, in some cases, it could be a board-level GigE camera. Anything that solves the customer problem. And to be honest, we have seen everything. So in some cases, however, we also have to admit that we cannot offer everything to the customer. And this is the cases where we decide to enter partnerships. All of these partnerships have the same goal. They are made to accelerate the development and to reduce the complexity for our customers. So one of those partnerships that we started this year, and we already launched the products to the market, is between Neosys and us, because Neosys are producing these amazing industrial PCs. And our goal was to make sure that our Acuva GMSL2 IP67 cameras are working out of the box with them. All with the goal to offer reliable performance out of the box. And of course, the major goal is to save time, to minimize the effort, and to give competitive advantages to our customers. And as you see, this IPC, for example, is designed for food factories, for outdoor applications, agriculture, smart city, and anything else. And it is IP66 protected, which pairs very well with cameras, which are also IP67 protected. And yeah, we know that when our technologies work together, then of course our customers succeed faster. And on this slide, we're showing just different kind of IPCs designed for autonomous mobile robots or also designed for drone applications, which perfectly work with our cameras. So one partner, one solution, complete confidence. This is what we stand for. This is what we are offering. And yeah, what speaks more confidence than actually giving a live demo? And of course, I'm taking the risk that something may go wrong, but nevertheless, we are confident that this is the way of embedded vision. So what I'm doing now, I'm going to launch our IC capture viewer on my laptop, which is running Windows 11. What we here see are one USB camera that is going to just show the setup. And the second device here is a HDMI to USB video converter, so that I actually can output the output of the embedded system on my, basically in my viewer on Windows. So let's start with the USB camera. And this is the setup that you see. So it's a live image. Before I start explaining the setup, I will actually power it on so that you can follow how it feels like when you unbox our reference design and start working with that. So let me now open the video source so you can actually observe how it is booting and what is happening. Back to the setup itself. So what we see here, as I said, two MIPI CSI-2 cameras that are connected to 2 out of 4 MIPI CSI-2 ports. So we can connect here totally 4 MIPI CSI-2 cameras. Of course, I have some mouse and keyboard. I have the HDMI cable that is going to this video converter so that I actually can see what is going on the embedded board on my Windows PC. And we are almost ready. You see it's booting. I will basically close this window so that we can focus on the embedded system itself. And what I recommend to our customers always is to start reading this README, of course, because we all believe that we know everything, but sometimes maybe there are things to be considered. And here in this README, we explain basically what is inside our evaluation kits. Of course, they are highly configurable. What packages have been installed, like Jetpack version, or any other software tools. How image acquisition is supposed to work, also by offering some example GStreamer pipelines, because this is what the customers use eventually. Of course, we offer links to documentation. Surely, we also offer information about how to reconfigure the driver. For example, if you switch to one camera to another. And when this is done, actually, it's quite simple. It is simply one click to launch our software. And as you see, it immediately finds these two cameras, these MIPI cameras, and you get a live image. So it is as simple as that. And this is our goal, to make it feel like a classical machine vision camera, GigE vision based or USB 3 vision based, where you actually don't expect any problems. You just connect it and it works. So this is nice, of course, but I suppose in most of the cases, our customers don't actually use our software. They go for GStreamer, and it is typically everything open source based. So I'm going to close our viewer and demonstrate a GStreamer pipeline, because as I said, this is what the customers eventually are going to do. So I'm launching a terminal, and I will actually simply copy one of these example pipelines here and paste it in the terminal and just execute it. And as you see, this is working out of the box. Exactly what our goal is. And that's all for the live demo. I'll switch back to the presentation mode, and thank you very much for your attention. I'm looking now for any questions.
So it's time for the Q&A. Are there any questions from the audience? There is a first one. And what is your policy regarding Raspberry Pi support?
We love Raspberry Pi for sure. We also love to sell cameras for Raspberry Pi. Logically, with USB, it is more or less out of the box. It works fine. With MIPI, it is a little bit different, because the driver framework for Raspberry Pi is libcamera. And libcamera does not support all sensors, first of all, that we offer ourselves. And also, there are maybe also some other limitations. So that's why what we do is to make sure that we offer let's say, a little bit more than just what Raspberry Pi offers, and support actually more sensors. So that's why, yes, it is. We don't sell Raspberry Pi itself, but we support it, and we make sure that our cameras are working fine. That's it.
And do you plan to support more some manufacturers?
Absolutely. We are looking very closely what is going on, of course, on the market. And as I said, embedded vision for us is not only MIPI CSI-2 and then GMSL2 or maybe FPD-Link. We perceive also USB, also USB 3, USB 2, or maybe GigE also as embedded. So we definitely, for example, had recently a project based on Qualcomm. And indeed, the customer was looking to use USB cameras, board-level USB cameras on Qualcomm, and that worked obviously out of the box too. So surely we're looking also at a new, basically, hardware that is coming out on the market, and are quite curious about it.
What distances can the FPD-Link GSML protocols overcome for a below 100 millisecond requirements class to class?
We offer cables from 1 to 15 meters. They work reliably, and the glass-to-glass latency is very interesting, because glass-to-glass means from the camera taking an image, going through the complete pipeline on the GPU, and actually displaying the image on a monitor. And of course, the monitors introduce also some latency. But it's interesting. We this year had a project indeed with FPD link cameras, and we measured glass-to-glass latency of 60 millimeters.
Are real-time below 100 milliseconds video streams generally possible with your offered product range?
Absolutely. As I said, it depends on the technology. If you look for real-time functionality, I will, of course, always recommend using MIPI or GMSL2 or FPD link, because then you have the direct connection to the image signal processor of the SOM. If you decide to go for USB or GigE, you typically copy some data. So this is not so real time, like, as I said, classical MIPI CSI-2 interfaces or derived interface.
As you mentioned it is in your presentation, plug and play embedded vision. There will be a panel discussion about this topic at the end of the day. And of course, you will be also one of our panelists. So I am happy to see you there. But I think we have time for last question. Is there any difference between the NVIDIA development kits and your NVIDIA reference design? Sorry for that, Andreas.
Absolutely. Absolutely, there is a difference. The NVIDIA development kits are obviously designed for development. Our reference designs are, of course, also NVIDIA based, but they are designed for mass production. They are highly customizable. We offer different carrier boards, which also offer also low-cost versions of them. And of course, if someone embedded, so when we speak about MIPI CSI-2 and derived interfaces, you cannot expect that you simply buy a different hardware and the cameras will simply work on it. This is not the case. So in our case, our solutions work out of the box. And when you buy an NVIDIA development kit and try to use a MIPI camera, maybe, it will not work out of the box and someone has to adapt the drivers for you. So that's a very essential difference.
Thank you very much for your presentation.